Well, hello.
Whoa. Hey, everyone.
Hello.
It's the last day of Build, and it's the first session of the day. Are you all awake? Can you say that loud enough that those who aren't will become awake?
You have to overcome...
Who's awake? Yeah! There we go. So, what's new in 𝗦𝗫13? Well, here's something that's not new.
Nope, not new at all, sorry.
We are the speakers. Mads Torgersen is me. I'm an architect at Microsoft, and I'm also the lead designer of this little programming language called 𝗦#.
And my name is Dustin Campbell. I'm a principal software engineer on .NET tooling in general, and also a member of 𝗦# language design.
So, I have 2 buttons. He has like 60.
I have the keyboard.
So, you'll be doing the hard work. Just a couple of things, householding. We're going to be talking about 𝗦𝗫13, right? That's a new 𝗦# coming to release near you in November. 𝗦𝗫13 comes out with .NET 9. And we, as always, we kind of lean into taking the 𝗦# that you already know, starting from there, and just making it a little bit better, right? And out of a host of small, tiny, and large features, we're going to focus on about 3 today that are probably the most impactful to you.
Yeah, the important thing about these is that they're things that you already work with, right? They're either language features where we're making them just better, or they build on concepts you already know from existing language features. So there should be no big explosion surprises in that sense, but hopefully you'll find it immediately useful.
We hope so.
Yeah.
And we're just about to get started. Dustin will switch to his desktop because we need slides. But before we do, you will probably have questions. We may or may not have time for questions in the room at the end. But we have folks on Pubble. In the room, we have 2 other folks from the 𝗦# language design team. We have Fred and we have Jared. And also online, we have Kathleen and Cyrus. So they will answer questions along the way and possibly throw 1 or 2 to us at the end if we have time to answer them. And for those who are in the room or at Build, we will also go to the experts area. We're officially scheduled, I think, at
like 11. Yeah.
We'll probably head there a little earlier, so you can come find us and chat with us about everything we show today. And we will, of course, have machines where we can go into the details of the bits we're showing. Outside of today, if you want to orient yourself about what's happening in 𝗦#, we have this, nowadays, we put preview implementations of our new features gradually through the release cycle into the actual compiler bits. And so if you compile with language and preview, you know, occasionally a new feature will pop up and you can play with it just in your release bits. And as we do that, sort of roughly in sync with that, we also put new documentation articles out, and that's the page that you see here.
Yeah, so depending on the level of engagement you want with 𝗦13, I mean, obviously there is some level of engagement because you've come to this session, right? But this is a way that you can kind of keep kind of a higher level of how things are happening. Right now, it's actually, this documentation page gets updated as features become available, right? So the features we're going to show today, only one of them is available, and it's on this list.
Yes.
But so this list, when you go here right away, immediately you'll say, well, this seems kind of short, right? And that's because these are some of the kind of almost always at the beginning of the cycle, these smaller features get checked in, things that are kind of like pent up or didn't make it into the last release. And so that's what you're seeing here today. But this is a dynamic page. This will continue to update all the way into November.
Yeah.
So
you look at this page today, it's kind of boring.
Yeah, yeah.
𝗦13, isn't that kind of boring? But that's just what's already done. If you go to the next web page, that's the compiler repo on GitHub. That's Roslyn, which is the name of where we built 𝗦#, the implementation. And we have a working set. We have a list of feature status, and you can see that list all the way until you hit 𝗦#12 there.
Even seeing which versions of Visual Studio they'll become available and when they're merged.
That's all stuff we are working on. Not all of it will make it into 𝗦13. Some of it is longer lead. Some of it may not happen for various reasons. But this is just, here you can go and see all the stuff that we're working on, what's the status, and you can click on the links on the actual features, and then that'll take you into the other repo, which is 𝗫#lang.
Yeah, so this is like really the engineering repo,
Yeah.
and then this is the design repo. This is where the C# language design team captures everything that we're working on. This is where people submit proposals, and there's discussion that if you want to get involved at that level, you're welcome to.
And there are wonderful meeting notes that Fred writes for every language design meeting that we do that are just available to everyone.
Yeah, so if the last page was how the sausage is made, this is like how the sausage is like shaped.
It's how it's designed.
Yeah.
Okay.
Enough.
Enough. We want code. So let's jump right into talking about the first feature here.
Yeah, this is actually very representative of the code that we left you guys with last year when we finished up our talk on C#12. It's not exactly the same, but it's roughly the same kind of code, and we kind of want to use this as a kind of a springboard into some new things.
Yeah, we want to remind you of collection expressions. So we have a couple of those in here.
Yeah, this is the big hit of C#12 in my mind.
Yeah, and the point of collection expressions, to remind you, is you can put one of those and it'll convert to pretty much any collection type you can think of. So depending on what the target type is, it'll build one of those. And the compiler's gotten really smart about doing the right thing for every given type.
Yeah, and the right thing in this case, because there's 3 overloads, which means it needs to pick one of those to produce something for. And in this case, because there's one that takes read-only span, which is this high-performance struct that really we can do with no allocation, that's what it picks, right? And so it produces essentially a collection, a read-only span that takes no allocation to produce, and then in the add grades, that add range method down here also takes a read-only span. It's part of .NET, one on the list of T APIs, and so it just when it for eaches that, there's no allocation there either. So this is the best for your application with regard to kind of hidden costs.
Yeah.
And so we select that one.
So that's a reminder from last year. But there's also one of these overloads is a params array.
Right.
We've had params array forever in the language.
Yeah, these are boring. These are from C#1.
But it does mean that we could take those square brackets away, and now you can just,
if you want to allocate, then you can do that.
Well, the thing is, now it will pick the overload that isn't the most optimal. Since probably we got generics and we had IEnumerable of T, people have been saying, why can't I just have a params IEnumerable? Because what they end up having is 2 overloads, an IEnumerable of T overload and then an array overload that's the params. Why can't the IEnumerable overload just be params?
Precisely. This is like the first language feature request of C#2 after generics came in. But now that IEnumerable of T is there, can't I do this?
Yeah.
And in C#13, we can. So it took 11 releases, but we eventually do listen and fulfill your requests.
We're not quick, but we're thorough. And also, we happen to now have this whole machinery for creating other types than arrays based on elements from collection expressions. So we can just go and plug that into IEnumerable.
Yeah. Now, we won't select that, right? We're still going to select, the original overload. We don't want to break the code by picking something different in this case.
Yeah, it's just better by overload resolution rules, right?
Yeah. So, but if I comment that out, surely, yes, of course, that does in fact work, and it picks params IEnumerable. And again, this has some of those hidden costs, but that might be fine, right?
Yeah.
It is certainly more ergonomic.
But if you really want the high performance thing, like what was picked before with collection expressions, it would be really nice if you also had params of span and read-only span. And that's it's more frequent but very highly requested feature for people who want to avoid allocations and are at that level of performance focus.
Right.
And sure, we can do that too.
Right. And so then in that case, we will pick the read-only span. Yeah. And so again, now, if we have in the libraries, when we add read-only span params overloads, when you recompile your programs, they will pick those, and they will suddenly just get a little better, a little nicer. And to remind you, some of those APIs, they're already going in. They're not in the .NET 9 Preview 4 bits that just shipped, but they should be there next time around. But that includes things like string format, console write line.
Yeah.
I just saw a PR open in WinForms for like all the like system drawing APIs. Make sure that we have read-only span params overloads so that things can just be more efficient by default.
Yeah, it becomes one of those features Stephen Tope likes to show off so much, where you recompile and everything gets faster. Like in combination between the language and the libraries adding these extra overloads, these params overloads, or putting the params on their existing span overloads. Yeah, so params is sort of the next turn of the crank of,
Cool. We were thorough.
Yeah,
it's good.
All right.
Cool.
Let's try something else. Like this is...
We did C#1. We talked about like how there was a request in C#2. Let's go on to like C#3.
C#3.
10 releases ago.
We're cleaning up one version at a time.
Just sweeping everything up. Yeah.
Yeah, so in C#3, I was around for the design of C#3 almost from the beginning. So that kind of dates me. And that's when we added auto properties. And we actually had a big debate because we knew from the start that auto properties was going to be a problematic feature. Right? It's great. It's a great shorthand if it does exactly what you want. But if you want anything ever so slightly different, you fall off the cliff.
Yeah.
And you have to write everything out manually. And it's like 3 times, 4 times as much code.
It's the worst, right? You got to declare a backing field, and now I got to take these semicolons and turn them into curly braces and write code in there. It's a mess.
So we were very much on the fence, but in the end we were like, this is so useful when you can use it, we're going to put it in anyway, and we'll see what we can do about the cliff. And here we are, 10 versions later.
Yeah, we are doing something about the cliff.
Doing something about the cliff.
We've tried in the past to kind of limit the cliff, right? We did like get-only auto properties. We've done, even a init could be looked at as a way of dealing with that. We added the initializers. These weren't there in C#3.
Yeah, you couldn't do that at first.
So we've done things to try and make it a little easier. But this time we just said,
let's just fix this.
Let's just do away with the cliff.
So as an example, let's say that we just want to do a tiny little bit of work in the setter. This is all right. We just want to we want to trim the white space off the ends of that name that comes in.
Absolutely.
Clean it up a bit.
This is what you always want to do, right? You just want to say, I want to say, do something with it, but say like, okay, value dot, take that and trim it, right? And I want to then push that into something. And in C#13, now I'm going to warn you, there may be some squiggles here because this is under active development.
Yes.
But Chuck is working very hard, and he's probably listening right now.
Right, Chuck?
Right, Chuck? Yeah. And so you will be able to assign to a new keyword called field. Right?
Yeah, field is simply a name for the generated backing field that you can use inside of the accessors. And it's actually just like you see value is coloring blue there. It actually, for our purposes today, let's just say it's a contextual keyword. It will be.
Use your imagination. Field is blue.
Yes.
And the squiggle is not there.
Field will be blue. Field will be a keyword only inside of property accessors, right? Contextual. Everywhere else, it'll still be an identifier.
Right. This one's taken us a while. We actually showed it last year, and it didn't make it into C#12, and it was heartbreaking. So we really want to get it this time.
So before we talk about anything else, just let's sum up. Auto properties now can have bodies.
Yes.
As long as a body is still left unimplemented, or somebody mentions field, it's still an auto property. We'll still generate a backing field for you, and everything is as you expect, except you can get at that in your optional accessor implementations now.
Yeah. The goal here is to be able to kind of encapsulate that property, right? Not to have this field just dangling out there that maybe somewhere else, and maybe it's a really large class and somebody messes with it, some other, you don't want that. You want to protect it, and so that was the goal of auto properties, and now they really do remain. They're still auto properties.
Yes, they're still shorter, and they still protect the backing field. But, hey, you can already say field today, right?
Yeah, this is the problem.
Okay, first of all, do you like this feature? You're going to use it? All right.
I think people will use this immediately.
Okay, I wanted you to be happy about it first before I told you the bad news. So you could... There will now be code that's legal today. Like if you happen to have something called field and scope, you're referencing it in a property, that reference will now be a keyword instead. And so this is a breaking change that's in C#. That's something we haven't really done before at this scale. It's not like a massive, but it's still like people will be affected by it.
This is a student class, so it's perfectly reasonable to have a field of study as a student, right?
And what we usually do when we have that situation, the design clashes with existing code, we say, oh, we're going to make up some really arcane, weird rules, and then they will be in C# forever, so that if somebody adds something called field, like way, way, way over there, then the meaning of code over here will silently change. Right? That's how we've kept backwards compatibility. And this time we're like, oh, this hurts in our stomachs. We want to do something different. We want to actually do the language feature properly. And instead of having a forever degraded experience with a new feature, we want to give like a small short-term inconvenience of say, like you may have to change your code a bit.
Yeah.
So the way we do it is that when you get the new compiler, you're still in a previous version of the language, probably. Most people are set up like that.
Most people, you'll install .NET 9 SDK. Your program, if it was targeting .NET 8, then it's still technically using C#12. Until you actually use .NET 9, you're not using C#13 yet.
But now the compiler will give you a diagnostic saying, hey, here, here, and here, you have code that will change its meaning in C#13. You're not there yet, but it will. Do you want to fortify your code against that?
Yeah.
Here's a fixer for that. And what that fixer will do is very, very simple.
Yep, it'll just use another feature of the language that's been there since C#1, where you can put an @ symbol in front of a keyword. You can actually do that in front of any identifier today. But really it's there so that you can have a keyword, have an identifier with the same name as that keyword, and you can disambiguate it. And that's what we're doing. We're just doing it in advance.
Yeah. So in these cases, you will get tooling help, and this is the fix, right? Just put the @ sign in front, and you're back to it working both in previous versions and still in C#13 the same way.
Yeah.
So that's how we can, this is the first time we try this. The tooling around this, the exact experience, there might be some road bumps. Help us with feedback, because we may want to do this again occasionally. We may even want to go back and look at like var or discards and say, can we make those a little better? Because they're kind of confusing today. So breaking changes, we're going to try to manage like these very limited breaking changes that have very easy fixes and give the language a little more freedom to do the right thing. Okay, you okay with that?
Yes. All right.
Okay, thank you.
Okay, so that's the first two. We did params collections, we did field access in auto properties. Now we want to show a feature that really we've only ever shown in slides. We've shown it before, but more of a vision kind of thing. And now we have some bits. And as I always like to say, they are indeed magma hot, but they're like surface of the sun hot this time. It's not just from a feature branch that's not in main. They're actually, these bits are built from an open PR. So
the standard rules of physics no longer apply near these bits.
Yeah. I'm actually going to roll this back a bit so I can.
We got them last Friday, built off of an open PR on a feature branch. Some things won't look, some things will be cheating a little, some things won't work yet. We'll try to point out where things will be better, but here we go.
Yeah, and we are again building on C#3, right? Fixing things for you in the past. No, this is actually building on a concept, right? How many people, I mean, everybody does, but how many people write extension methods to use in their code? Yeah. They've become extremely popular. I mean, when we introduced them, they were about query expressions and links so that we could transform those expressions into selects and wheres and all of that. But people write them a lot. And the reason I think people write them, primarily, there's a compositional kind of architectural sorts of reasons for doing it, but also it's just discoverable, right? There is real power in being able to press dot and getting everything here and getting this parse as JSON down below. That's in IntelliSense. And it's there because I've declared an extension method right there, right? So there's real power and discoverability when you're writing code. And also there's kind of like this idea of being able to write little DSLs. We do all those sorts of things with it. So they're just very, very powerful and became very popular.
Yeah. The only problem is the only thing you can sort of fake is instance methods.
Yeah.
Any other kind of member you can't do. And even in C#4, even the very next release, we were hard at work trying to see if we could make extension everything, like if we could make other kinds of extensions. And the syntactic paradigm of like hijacking a static method just didn't work.
Yeah.
We let it lie.
To age myself, I arrived when C#4 was in development, and they had already abandoned extension everything and moved on to like, can we just do properties, extension properties? And they eventually said, it doesn't feel right, and backed away.
Yeah.
So like, this has also been on our minds for a long, long time.
Yeah. But so we needed to take like a step back and a new syntactic direction for extensions in order to uniformly scale to all the different kinds of members, at least ultimately, that you might think of doing as extensions. And so in this example, we have a call of a static method. And so wouldn't it be great if we could like get to where we have a static extension method?
Yeah, this is weird, right? You add this parameter and all that sort of thing. And so it'd be really nice if I could write that as an instance method. And if I introduce this new kind of thing that we call an extension, and we can write that here, I can say this is actually an implicit extension. Let's just do it right now.
He's doing it.
I'm doing it. Say implicit extension, right? And then I can say for the type that I'm extending. So we're going to make an extension for string, okay? Now, this extension method, this old school C#3 extension method, doesn't make sense anymore. We should actually write that as an instance member, so as if we're just augmenting that type in the for, the underlying type.
Almost as if you're writing a partial class or inheriting.
And that still works. And that's how, with extensions,
ladies and gentlemen, we've recreated a feature from 10 versions ago. You're welcome.
Yeah, we have recreated the syntax for that feature. But again, it's not conceptually new. This is things that most people raised their hands, and that was validating for this, right? That we're going this direction.
So you just put an instance method there, and it became an extension method. But you also have a static method in there.
I have a regular static method here.
Is that an extension static method?
It may be. So if I go then instead of, again, it's the power of dot, right? Now if I go to string as a type, and I press this, you'll see that create indented is there as a static extension method, which is something you could not do before.
Yeah, so now you truly get that transparency of the thing that declares the extension methods, and it can just sort of appear as if those things are on the underlying type, as we call it. And we call these, like I think the formal name for this feature is extension types. Because you see, it really is a type declaration.
Yeah.
It has a type name, but it doesn't really introduce like a full new type. It just says, I am that type with something extra, with some extra functionality added. You can't add like state. We don't let you do that. You can't override methods. But you can add extra things, like with extension methods, in a syntax that looks like a type declaration.
I mean, you can see here, I press dot again. Inside this method, this type, I have access to all the public members of string. I don't have access to like internals. It's not like I'm actually inheriting. Yeah. I'm writing, under the hood, you can think of it as augmentation, or if you really want to know, it's like writing a struct wrapper around it. So it ends up being transparent, zero cost, essentially. Yeah. And just adds things. Also, just to kind of drill home that we have a scope here. We're in a place where when the members we have are it's as if we're on string itself, right? And so you can see maybe you can't see, it's hard to see, that's actually grayed out because we don't need to say string.empty, we can just say empty here because we're in the space of talking about string and its members, right? Yeah. So name lookup works like that.
Okay.
All right. This is cool.
This is cool. Let's play with this a little more.
Okay. I actually want to do some things with this. So
there are other kinds of members. So let's take now we're taking this example here. We're taking some JSON in a string and we're turning it into JSON element.
So there's customers. These are an array of objects that have names, and orders, which are an array that have descriptions. Okay. And Mads likes beans, rice, and pickles. Okay. That's cool.
Let's dig into some of this data. Let's just start traversing it. Yeah,
I'm going to delete this guy right here. And then we need to get the customers out. And we're using we're using system text JSON. Mm-hmm. So it has its own particular API shape. And I can walk up to that data property up there, and I can ask for that customer's element. Mm-hmm. Okay? And then I could for each over that.
So if you think this is cool, this is already there.
This is
not,
just API, yeah.
So it's still cool.
But when in system text JSON, when you enumerate something that's like this is still, all of these end up being JSON elements.
Yeah.
And when you enumerate a JSON element, and when it's going to be an array, you call this enumerate array method. All of this is pretty much, I believe it's allocation free to do this work with JSON. And then we can pull out, say, like, if we recall, those customer objects had name properties. Yeah. And so again, it's kind of tedious.
It is tedious. I don't want to keep doing this. Now we have to say get string.
Yeah, and I gotta not type incorrectly.
Yeah,
get string.
If you had a typo in there just once, it goes.
Yeah, this is it's very loosey, right? We're kind of working with loosely typed data.
So I have an idea. Could we do like I'm just pretending I have it now. We actually prepared.
Yeah.
Can we do this
so
as an
smooth.
Could we do an extension property to could we just say .name?
Yeah, that would be great. If I could write this.
Yeah, and just it would just be there, and that extension property does the unsafe work, but I actually just get a string back, and I have IntelliSense and all of that stuff on it.
Yeah, so magma hot bits mean, folks, that IntelliSense may work against us. You're welcome to laugh. It's fine. It's expected. All that comes later. So I would declare an implicit extension. We'll just call it customer, right? And then we can put on here a name property. And let's just, I should have copied that code earlier, but
you can write it again.
I can write it again. We can say this again, get property, name, and then get string. And we get a little nullability warning, but you know what?
Yeah, we think it's there. We just saw the data. It's there. Override.
We're good. Don't ever do that. Yeah.
So, well, we're doing weekly type stuff anyway here. Who cares? If it blows up, it blows up. Okay.
But look, the squiggle's gone.
It works. Extension properties, ladies and gentlemen.
Although, I think I might have spotted a problem.
Yes.
Because this is just an implicit extension for any JSON element, right? Customers is a JSON element, so I could do this too, right? And it will think that's fine.
Yeah, but it'll blow up because that's not what we meant.
No, this was because this doesn't exist there. It's an array.
So we're so close. Like we have this way of putting things on there. We just don't want to put it on all JSON elements. We only want to put it on some JSON elements. So how can we make an extension for just some JSON elements? Well, that's where we get to why is it called an implicit extension. That's because it's an extension that implicitly applies to all values of its underlying type, of JSON element in this case.
Right.
But we could also make it.
Go ahead. Yeah, we could make it, what?
Any guesses? Yes.
Explicit.
And now it doesn't.
Right. And so now
we made it not work.
Yeah. Because it's just a JSON element, it's no longer implicit, right? So how do we address that? Well, in future bits, you should be able to do all sorts of things, where we can kind of take a JSON element and kind of easily coerce it, implicitly convert it to customer in some way. So I expect, we haven't exactly done all this yet, but I expect I should be able to do something like that and then turn it into a customer, which does work, but that kind of fails down here, right? So.
And that should be clear. That's just because of the bits we have right now.
Right.
This is how it's supposed to work.
Like the surface of the sun.
Yeah, I get a JSON element. I choose to put on the glasses of customer and view it as a customer by converting to the extension type called customer. Here it really comes to use that it's a type. We can implicitly convert to it. Now we're viewing it as a customer, and now it has a name. Except we can't yet, so we cheat a little. Yeah,
so we're going to cheat. I'm going to tell you that we're going to cheat right up front. We added in our own little extra extension method, our own enumerate array that does the coercion,
this is no longer the
conversion for us. But expect that we'll be able to do that in final bits. And so now I could type var here if I wanted to keep that.
And it's still customer. Do we want to try to run this just to see that?
Oh yeah, we should do that. We should ignore the man behind the curtain kind of thing. Yeah, okay.
So while that takes a while, maybe, sorry, just note here, explicit extensions, essentially, they're lightweight type. They're thin wrapper that you can put around something else. In this case, the something else that we're putting it around is weakly type data represented as JSON. But you can imagine in a lot of other cases, you want to look at certain data with specific with a specific angle, with specific enhancements, without that applying to all of that data of that underlying type. And that's what's happening here.
Now, I want to point out that it did take a long time to build and run, and I want to address that. I just know that that is because these are built bits. They are not optimized in any way. And also, the way we kind of bring that compiler in tends to be a little slow first run. Next runs should be faster. So,
okay, so let's breeze through some fun here. So we have a weak data model in JSON. Let's write a strongly typed object-oriented overlay for it.
Yeah, so we have an extension for customer.
Yeah, let's do one for order. You can actually copy-paste the other one.
Oh, you're right. That seems so sensible.
I know. You know, I am the architect.
I'm out.
Don't let me near that keyboard.
All right. So order, if I remember up here, order had just a description property.
Yeah.
Okay. And so we can kind of do the same thing here. Whoops. And then I will go ahead and type this 100% accurately so nothing fails. Okay. Yeah. In there. And so now we have that. But what we also want is that customer has an array of orders, right?
Yes.
So let's go ahead and add another extension property here.
Make it an enumerable of order.
Mm-hmm. And then we can do a similar thing to what we did above, where we can say get property, orders, and I realize that I've forgotten the name of that property, which is why I'm getting all sorts of embarrassing squiggles. It's okay. I don't feel bad. You guys do. It's cool.
Yeah.
All right. And we can pick our special little enumerate array that we won't need in the future. And now we have an orders property. And so I could then take this customer and I could for each over, say, order in customer.orders. And I could write, you know, something like, we'll say, so-and-so ordered order.description.
Yeah.
Right? And we should be able to run that. And hopefully that goes a lot faster. See, I told you.
There you go.
Told you it's fine.
And so
this is cool.
This is cool. It's like TypeScript, right? Anybody here use TypeScript? You know, JavaScript, all objects are just dictionaries. They're like our JSON elements here, and they just put types on top. And you know, most of the time it works out. This is kind of similar, and you're like, but this isn't really strong typing. But it is to some degree, right? Because you only have one place to make the typos, like you're abstracting out where you're actually giving those strings again and again. And B, now you have this model that through IntelliSense you can discover and verify that the code you write matches the structure you expect. Now, if the data doesn't match the structure you expect, that's a different problem. But if you upfront say, like, this is what I expect it to look like, the rest just falls out. And that's actually still kind of cool.
It is cool. You could even write like a query expression, keep it with C# 3.0. You could query over this data just with normal link to objects, and it's fine.
Yeah.
So.
And just to, you know, okay, is it a little tedious to write these? Well, they're not actually, these explicit extensions aren't bad to write, but you are like writing all that gunk in all the implementations, and it's pretty repetitive. You could imagine a source generator doing that for you after looking at like some JSON schema or maybe some examples of the JSON you're expecting, or you know, TypeScript types that somebody already wrote. Like you parse those up, you generate out your explicit extensions, and you know, you take your root JSON element and you implicitly convert it to like the type you created for the root, and from there on, you just statically type without any effort.
And it's not just like we statically type it, you get this free, like literally like cost-free static typing.
Yes. So we think there's a lot of there's a lot to this scenario too, about like the strongly typed shims, if you will, over weakly typed data.
Yeah, so we can do these cool things, but also, these will be like the things you use extension methods for today, that discovery, this is the same kind of thing. You get that discovery on dot. So I think it's going to go, I think it's going to go far.
You can use this, you think? Yeah?
Yeah.
All right.
Well, if you're still on the fence, we have a couple other ways to show you, right?
Yeah. So just to kind of run the gamut, we haven't shown an extension indexer yet. Here's an implicit extension again. So it applies to all uint 64s. And it's just this idea, you know, I have this unsigned 64-bit number. Why can't I have an indexer that accesses every bit of it as, you know, and as a bool.
And I could tweak it, right? That would be cool. Yeah. That would be super cool.
Add that. And we don't need to get too much into the implementation of it. Just witness here that there is an extension indexer that actually, like if you go write it...
I could say, like, we could do things like say, well, okay, take like bit, I guess, 2, and we could say, like, grab bit 0 and OR together bit 1, and maybe just take this bit, this right line and copy it down there. Or we even have a reverse method on here, right? That just, and again, this is an extension method that just appears as part of this.
And uses the indexer for its implementation.
Even uses implementation of this. Here's a static extension property.
Yeah.
But we could say, okay, let's just reverse those guys. Whoa, whoa, whoa.
Number equals numbers.
And this one, I'll ignore the lack of intelligence. All right, and I can paste that again. And if we run this code,
you're going to see some big numbers.
You're going to see some big 1s and 0s, which is very exciting.
Yeah.
I understand that again. But you can see that, okay.
You can clearly see, you can get out your microscope.
Very closely, right here was bit index 2, and we flipped it.
Yes.
Yeah.
So, and if you just very quickly, briefly look at this code example, and we'll move on. But inside of the implementation of this indexer here, you see we say this.value in a few places.
Right. This is our hacking.
That's our hacking. Like you can just, because this is an extension of 𝗦𝗲𝗀𝗀𝗀𝗀, right? You would be able in the future to just say this.
Yeah.
And you're talking about the 𝗦𝗲 with its extra enhancement.
You should be able to do it exactly like this. Today, the bits don't work, but they're getting there.
Yeah.
Julian is working very hard, and that's why I invoked his name.
He's probably also out there watching. Right?
Yeah.
Okay.
No pressure.
One more extension example.
Yeah, one more. And this one I think that's a little more off the beaten path, but it's something that you might not expect.
Yeah. This is like, okay. So using aliases, right? They're so cool. We all love them, right? No, they're disappointing, is what.
Yes, they're disappointments. Yes.
And we get feature requests all the time. Can you make them better? Can you make them better? So I would like this one to be generic, for instance.
Yeah, we get this all the time. We have talked about this ad nauseum. Can I ever do this? And then I could pass it in here.
That'd be cool. You could even have like a constraint.
Oh yeah, we could add a constraint. And like this raises all sorts of questions, but then it also has a lot of, I would say, ergonomic issues with using it, right? Because it's a using alias. So you can only use it in one file. Well, we fixed that. We can make it global.
You can make it global.
But then what if you want to like export it from your assembly? Now we need to be able to say like, okay, it's got to be public. And at this point, we've reached a little bit of silliness, right? It just seems like we're, using is buckling under the weight of what we'd like to be able to do, and maybe it's not the right feature.
But hang on, we just saw explicit extensions a moment ago. And they're really just another name for the same type, but with some extra members added, okay?
Yeah.
It's an alias. So what if we do that, but just don't add any extra members? That's an alias, right? That's just what it is.
Okay, I'll just replace using with explicit extension.
Explicit
extension. That's going to be fun to type. All right, and then we can say, oh, we need 4 instead of the equals.
And 4? And we don't allow the semicolon yet. That's just a bit. I think, most type declarations can have semicolons now. This will be able to. So it'll just be like, we'll put curlies for now. And
of course, I can come down here now. And so I've declared an extension that does take that generic parameter, propagate it, add a constraint.
Yeah.
And I come down here where I do get, the parameter help in the generic list. And I can say, well, I want that to be like, the string data item. And so then, and I got to close that extra angle bracket. 2 angle brackets like that, they always make me itch.
I do that every time.
But then you can see here, right, that in fact it's calling the add method, and data set itself is an explicit extension of T, where T is constrained to data item, and T is actually filled in with a generic argument, string data item. So.
And by the way, don't you just love how using aliases make you put the full name of every type?
Oh yeah, we don't need that anymore, right? Yeah.
This is just an ordinary type declaration. It can use the imported names, right? So there you go. You have better aliases, like they just fell out of this feature we were doing. Like, oh, we don't need to do more about using aliases. We have a better feature already.
Yeah, all those places where you might say, oh, I got to go write a new class. I got to go write a new type, right? These are just these transparent, beautiful wrappers that are very cheap and make these kinds of scenarios just light up really easily.
So with that, we're actually through, and we have A good 5 minutes left. We have time for 1 or 2 questions. I want to first go to our Pubble folks and see they don't have any.
They're shaking their heads.
So if anybody wants to ask a question at either of the mics 1 or 2, you're like, oh, I didn't know this was going to happen. I didn't think of a question. Yes, somebody who's close to the mic. And then meanwhile, somebody else can sneak up. Mic 2, go for it.
Thank you. Great stuff, guys. Hey, could you go back to your bits example, the previous one?
Absolutely. Are you going to poke at like the sneaky things we did?
No, it doesn't. You give a name to your extension type, bits for 𝗦𝗽𝗲𝗀𝗃64, but you never use that name anywhere. Is it possible to leave it off?
We discussed that. The reason it can be nice to have, you know, with old-fashioned extension methods, occasionally they clash and you have to disambiguate. And the way you do that is you call it as the static method on the type where it's actually declared, right? So you have a fallback. And we figured it's good to have a name for that same reason, that you can, in fact, go and coerce your thing to that type.
Yeah, you could cast it to bits and then make sure you're calling the right thing.
So the little thing here is that implicit extensions are actually also explicit extensions. You can use them as the type, just as you could with the explicit ones. They just additionally show up by default on the underlying type. So using them as a fallback seems useful, and so we haven't really gone to the, can you just leave them off? But maybe, I think it's kind of likely. We will certainly look at it. It's kind of likely that we would. That's a really, really good question.
Yep.
Yeah, good thinking on that. And I don't see any other people by mics.
They're
So we
all
could go to
deeply satisfied.
we could go back to slides. I think it's button 3.
Yeah.
Okay.
Hey, Mads.
Yeah.
Oh.
I do have one question for you.
Oh, feel free.
Great.
Yeah.
All right, so you've shown extensions for structs and classes. What other types of types can I extend with extensions?
So the idea is that part of the reason why, actually, let's flip back for a second.
Yeah.
Part of the reason why we use the for keyword instead of just the colon, there are several reasons, is that the kinds of things you can write there is a bigger set than if you're doing inheritance or interface implementation. For instance, you could put an enum or an interface or a delegate type or a type parameter that you just got to your generic extension that's constrained by something, you know? So there really isn't a reason why we should limit ourselves to the things you can normally inherit from or to name types or whatever. So yes, we haven't really shown the power of that. To be honest, I'm not sure if it works yet.
Yeah, we're just starting to dig into this, yeah.
But if you have an enum and you want to add some properties to it, you know, be our guest.
Yeah.
Yeah.
That's why we have the syntax we chose is really, and you said it earlier, but just to kind of reinforce that, is that we want this to be able to scale.
Yeah.
So not just to being able to scale to other members, right? In C#13, we're not going to get every kind of member, right? It's unlikely. We need to get this feature out there, and so we're really aiming for like methods, properties, instance, and static on those. And then over time, we want to be able to say, well, maybe we could do other things.
Yeah, extension operators.
Absolutely.
Extension constructors.
Yeah.
Extension, you know.
Imagine the fluent assertions library if you could just use equals equals now because there's an extension operator that's being pulled in, right? There's a lot of really interesting, especially in those kind of DSL spaces where there's really interesting things that can happen.
Yeah, and a lot of really interesting challenges that we have to solve.
Yes, and a lot of challenges.
but hey, we're starting on a path now. As Dustin said, the core scenarios, we're planning for those to be in C#13. And maybe even this indexer thing won't work. Maybe we limit it all the way down to just methods and properties. But you will tell us, okay, by volume of voice together, what is the next important thing to do? And just like with pattern matching and records and so on, over a couple of releases, we will use that feedback loop to flesh the feature out and make more and more scenarios available to you.
Yeah, I mean, it's kind of like, in the past, we did C# releases over every 3 years, right? With a new Visual Studio release, way back in the day. Some of you might not even been here for those days. And now it's still like that. It's just that you get to see it about once every third of the way through that kind of that design process. Some of these features take a long time to really get them fully fleshed out.
Quick one from you, Fred.
What about extensions?
Extensions, that's another good question. We're actually thinking that to potentially disallow that, but I'm not sure, and instead have actual inheritance between extensions, maybe even multiple inheritance. But we are not going to go into that, obviously, now, and that is not going to be in C# 13. So we're kind of reserving judgment on that until we flesh that part out.
But the syntax should scale to that.
Yeah.
So.
And so just to close off the last 30 seconds, you know, come meet us in the experts area if you're here today. Go check the resources we showed in the beginning are at this URL, like they've been gathered as a resources thing for the talk. And also, you know, .NET 9 is out now, so go download that as well. Go play with the new things and tell us what you think, and help us make the release in November be awesome.
And one last thing with that, just remember that C# 13 is not fully there yet.
Thank you very much.
All right.